Welcome to the Zset training session series. In this session, we are going to discuss the paraview reader interface for Zset format files. The reader is developed as an external plugin and is version specific. By this, we imply that the Zset reader plugin is compiled for specific versions of paraview and Zset. In this tutorial, we illustrate the features of Zset reader plugin, which is compiled for the latest official Zset release version, that is Z9.1.4, and the last official paraview release version, that is 5.11.0. To start with, we download the concerned Windows or Linux version of paraview from the website. To facilitate the use of paraview, we have created a script named zparaview that can be launched from the command prompt like any other standard Zset commands. For this script to work, we need to define an environment variable pvroot. As shown on the screen, the pvroot points to the downloaded paraview folder. In comparison to the previous Zset Reader plugin, apart from being able to read the Zset mesh and result files, we have incorporated some of the commonly used mesh visualization features into this plugin. For the ease of utilization, we have grouped the Zset related filters into buttons as shown on the screen. Each of these buttons have specific functionalities. When the mouse is hovered over these buttons, the functionality is displayed as a help text. These functionalities include Lset, Nset, or Bset extraction with minimal user interference in terms of filter options. We will look into each of these functionalities using a Zset example. Here we have chosen the ironing simulation example performed using Zset. As you can see, the concerning Zset result UT file has been loaded. On the left pane of the paraview interfaces, we see various mesh sets present in the results. The Lsets, Nsets, and Bsets. We also see that the selection of these sets are not enabled by default. This is to save memory and to let user choose the sets of his choice that he would like to visualize later as filters. For demonstration purposes, we select all the Lset, Nset, and Facet data. We need to click on the Apply button for the selection to take effect. We select the warp by vector paraview filter to visualize the deformed configuration. We can quickly look at the simulation results by clicking the play button of the animation. We now try to extract a mesh Lset of choice. For this, we click the relevant button from the Z filters list of buttons. As indicated by the help text, we need to choose a cell field starting with the string Lset. When clicked, we can see that we have potential choices of two Lsets, namely the Lset bot and the Lset top. So we could select one of them. For example, let's select Lset bot and then click apply. We see that this filter has been applied on the warp by vector source, and here we just see the Lset bot. Each of these filters are applied on the active PV object selected from the tree. So in this case, we have applied this filter of Lset extraction on the warp by selecting the warp by vector, which is the deformed configuration. Let's say, for example, we have chosen the undeformed configuration as the active object, and now we try to click the extract Lset, for example. And in this case, let's now select the Lset top and then click on apply. As you can see here, in the Lset top has been extracted, but on the undeformed configuration. So in paraview, it's important on which object, in which paraview object present in the tree is being selected to apply the filter. As we have seen, each time a filter is applied on an existing PV object from the tree, the visibility of the source object is set to hide. We can enable the visibility of any object from the tree as required at any point of time. Also, we have seen that the Lset filters that we have just applied are automatically renamed according to the name of the LSET chosen, as LSET bot or LSET top. This makes it easier to have a list or track of all the filters directly by the names. Let us now apply the Nset extract filter. For this, we choose the default configuration paraview source from the tree and click on the button Nset extract. We need to pay attention to choose from the drop-down only the set name starting with Nset. In this case, let's choose the Nset if top. This will extract a list of points belonging to the Nset chosen. As you can see here that there are list of these points that have been created that belong to the Nset if top. As you can see here, there are various options for this particular filter that we've applied. Here you can see that there are a lot of representation options or other property options of this particular filter. We can manually do it from here, or we have programmatically chosen the best representation properties, and for that to take effect we need to click on the next frame just for it to be applied. As you can see here, by default now the representation style has been changed from surface to points in this case, and also the default point size is kept as 8. You can of course change these, play with these parameters. Let's say for example make it 4. In this case you can see the point size has decreased, or even increase them, like I don't know, like 20 for example. So you can see that you can play around with these options. By default options have been set programmatically in the plugin, so of course you can change them as you wish. But here we can see that the points have been extracted and created for the Nset if top on the deformed configuration. Not only that, having extracted these points, we can not only just visualize them as mere points, but also we can visualize the various fields concerning. For example, if you want to visualize the sigma, for example, in this case, or you could also visualize the the strains, or you can visualize the displacements. In this case, if you have displacements, then it's y displacements or different components of the displacement vector, as well as similarly different components of your sigma vector, that is the stresses in y direction. So it's not just about mere visualization of points, but also you can visualize the various fields available from the simulation on these points, and you can see how these fields evolve as you progress in your simulation. We have also tried to use some of the native paraview error handling features to suggest the user in case of errors made in the plugin utilization. For example, when we click on the Nset extraction filter, say for example, we now would want to select again apply an Nset filter. And in this case, instead of choosing from the available list of scalar field data, instead of choosing a scalar field that starts with the name Nset, as suggested by here by the help text, which says select name starting with NZ. So instead of that, if we select a name starting with, for example, a bset, and then click apply, here we can see that it has given a valid error message saying that select a valid NZ starting with NZ. So in this way, we are trying to give the user appropriate error messages to help him use the plugin in the right intended manner. Similarly, we can visualize Bset as 2D surfaces. For this, we click on the Extract Bset Filter button. As suggested by the help text, we select a scalar field that starts with the name Bset. After clicking Apply, we can see that the 2D surface has been extracted. As explained earlier, we can not only extract the Bset but also visualize the various fields available from the simulation results. So in this case, here we are visualizing the displacement field. Here we can also visualize the stress field, the various components, the magnitude. We can also click visualize the animation of the simulation along with the field data. And as usual, you can activate other sources of the paraview objects in the tree. For example, you would want to visualize this along with the total geometry. And in this case, let's say we trying to use some of these features like opacity for the whole body, but then just highlight the interface. So in this case, you can also simulate visualize the results using these extracted surfaces. Let's say, for example, you would want to also, for example, let's say, since we have already seen the Nset filter, let's say, for example, we would want to extract an Nset as well. So in this case, let's say we apply an Nset and select one of the Nsets. And as mentioned earlier, in order to apply some default representation properties for the extracted Nset, you have to either click on the previous frame or the next frame just for it to activate. And let's say we would want to visualize the displacement in this case for the Nset. And now we can actually visualize this simulation results in such a way as well. So far, we have visualized the Z filters to extract L sets, N sets, and B sets data. Another handy attribute of the B set is the normal orientation. For an extracted B set, we can visualize the normal orientation by applying the B set normal extraction filter. So here, before applying, as indicated by the help text, we have to select the input source for this filter is a B set. So for this, let's activate the B set, extracted B set filter, and now click on the visualize B set normals and then click on button apply. So here you can see that you can now visualize the normals. So, or you would also want to have them as a default uh, solid color. For example, height of these normals. How do you can scale them basically by a factor, as you can see, and also these can be part of the visualization. Click on apply. Now you can see that this is a second surface, and on this surface also you can extract bicep normals. Here you can also scale them similarly, like with any factor of your choice. So yeah, this is how you can basically use these Z filters that we have discussed so far, like L set extraction, N set, B set extraction, to extract various geometric features of the mesh. And also along with that, an additional attribute of normal orientation can also be visualized as arrows by using the visualize bset normals Z filter. So far, we have looked into the Z filters to extract various geometric features to aid visualization. We now move on to the integration point data visualization filter. The input source for this filter is the loaded Zset results file. We apply this filter by clicking the Z filter button for integration point data. Using this filter, various tensor fields can be visualized at the ghost point location. For example, the stresses and strains here. You can visualize them at the ghost point location. Currently supported element types are hexa and tetra elements. So for example, the pyramids typical to Zcrax applications are not supported for ghost point visualization. in this current version of the plugin. In addition to the standard capabilities of reading ZSET related data, we have now incorporated a new feature that allows the user to read directly the Ansys RST result files using Parview. Here we visualize an ironing simulation from Ansys. For this, we load the results RST file. For this, you can click on the open button, and on the file type filter, you can actually select Ansys results, which is now available, and then directly select the results file and click on apply. As you can see, now you can load the Ansys RST file results file directly into Paraview using the Zset reader plugin. And now let's quickly visualize, for example, the displacement. In this case, apply the deformed filter, and then you could click on play button. Yeah, so this is how we can actually visualize the Ansys results as well within Paraview using the Zset reader plugin. So this was about the Zset reader plugin for Paraview. For any queries, you can contact the Zset support team on the displayed email address. Thank you.